Hello, dear students. This is your lecture 5 continued. We are starting a new unit in this lecture, that is unit 2, and the first chapter is uniform motion. So, in introduction part, let me first tell you uh, what is mechanics. Mechanics is the branch of physics which deals with the study of motion of material objects. It is called mechanics. Mechanics has three parts, which are statics, kinematics, and dynamics. Statics is the branch of mechanics which deals with object at rest, the objects in which velocity is zero when objects are at rest, or in a better way you can say an object is at rest and there is no net force acting on it. No net force is acting on it and it has no वेलोसिटी इधर, तो वेलोसिटी भी जो है वो आपकी ज़ीरो है। दूसरे नंबर पे हमारे पास आता है काइनेमेटिक्स। काइनेमेटिक्स जो है ये हमारी वो ब्रांच है फिज़िक्स की जिधर हम ऑब्जेक्ट्स को स्टडी करते हैं जो मोशन में होते हैं, बट हम इनके सोर्स ऑफ मोशन को, यानी कि हम इनको पढ़ते हैं फोर्स को इग्नोर करते हुए। वी इग्नोर द फोर्स, we just only study the motion. And the third branch is dynamics, in which we study the motion as well as we study the cause of motion, and cause of motion is force. So we also study the cause of motion, that is force. So that is the difference between statics, kinetics, and dynamics. Next, objects in motion. So rest and motion are connected. You might have seen so many objects which are in motion: car, bike, fan, train, aeroplane. There are so many things which are in motion and we can easily identify them as they are changing their position with respect to time. At this point I would like to tell you that rest and motion are connected. Suppose you two friends are going in two different cars in same direction on same road with same speed parallel to each other, then for them they are at rest for each other, because their position will not change with respect to each other as they are moving with same speed. So but at the same time, for an observer which is standing on road, both the cars are moving in one direction with very high speed. So for that stationary observer, both the cars are in motion. So what is this example is trying to explain, that motion and rest are relative, they are not absolute. There is nothing which is in absolute rest, or there is nothing which is in absolute motion. So ऐसा कुछ नहीं है कि अर्थ रेस्ट पे है, सन मूव कर रहा है, सन रेस्ट पे अर्थ मूव कर रही है. There is nothing like absolute rest or absolute motion. And then we are having types of motion. So first we are having rectilinear or translatory motion. Rectilinear or translatory motion is when an object moves in a straight line. Consider a block which is moving in straight line, its position is changing with time. This is known as rectilinear motion. What is the difference between rectilinear and translatory motion? If the distance covered, there is a very slight difference, is of the order of size of object itself, it is known as translatory motion, otherwise it is rectilinear motion. We will also further we will explore it when we will study concept of point mass. Circular or rotatory motion, so they are also very similar, but again there is a difference. You can have a difference here, like consider this is sun and earth is revolving around sun, or you can say earth is in circular motion around sun. So that is circular motion. While on the other hand, rotatory motion is like when an object is rotating about its own axis. For example, earth is rotating about its own axis, so that is your rotation, and that is your circular motion or revolution. Third is oscillatory or vibratory. Here you can also remember it with very simple example. You will never forget this example, whether your mobile phone vibrates or oscillates. So I'm sure no one is having a phone which is oscillating. All the mobile phones are vibrate. So when the object is in to and fro motion and the displacement covered is much smaller than the object itself, it is known as vibration. And when the object is in to and fro motion and the distance covered by object is much larger than the ऑब्जेक्ट इटसेल्फ देन इट इज़ नोन एज ऑसिलेटरी मोशन। तो यहाँ पे आप देख सकते हो कि जैसे पेंडुलम का अपना साइज तो छोटा सा है, जो ये मैंने रेडिंग से दिखाया है। एंड देन यू कैन सी विद ग्रीन इंक आई एम शोइंग यू द एम्पलीट्यूड विच इज़ मच ग्रेटर देन द साइज ऑफ ऑब्जेक्ट। So when object is in to and fro motion, to and fro means one time going left, then other time going back, and like this motion. So this is motion is known as to and fro motion. So in both the motions, or oscillatory or vibratory, there is to and fro motion. But if the amplitude is much greater than object itself, then it is oscillatory motion. And if the amplitude, which I have shown in green, is much lesser than object itself, which I have shown in red, then it is known as vibratory motion. Then there is concept of point mass object. This is very important concept, pay full attention. When an object is moving, like I'm considering a table, and on in this table a book is placed. Now if you will move this book to the left hand side, then you will reach on this point, and you know that if you will move it any further, little any further, then this book will fall. Up to 50% this book will not fall, but if you will move this book more than this distance, this book is gonna fall down, because now the half, more than half of the book is outside the table. So it means that we cannot ignore dimensions of book, which I am showing in green the dimensions of book, and I am showing in blue the dimensions of table. So when dimensions of object which are in motion cannot be ignored, then we cannot consider the object as point mass object. On the contrary, opposite to this, consider an example: a bus is moving between two stations, like a bus is moving from Rohtak and it's going to Delhi, which is approximately 75 kilometer distance. And you know that what is the size of bus on this length scale. On this length scale, a bus can be represented by only a dot, because individual dimensions of bus or car will not matter in such a long distance. It make no sense that if you are coming from Delhi and I'll ask you, instead of at what time you arrived Rohtak, and I will ask you at what time bonnet of your car arrived Rohtak, or at what time front tires of your car arrived Rohtak, or at what time diggy of your car is arrived, because we are considering car as a whole, as a single point, that the car is arrived at a particular point. So we can consider objects as point mass object. Here bus is considered as point mass object, and dimensions of the object which are in motion plays no role. So that is the concept of point mass object, and we are going to use it much often as we will study it in physics. Okay. And the motion in 1, 2 and 3 dimension will discuss in next lecture, because this lecture is already about 9 minutes. So but let me give you a little brief, that there are three space dimensions, and if only one dimension is changing, then object is said to be in one dimensional motion. Like for this a object is in one dimensional motion, and let us take a green object. It is moving such that both x and y coordinates are changing, then it is said to be in two-dimensional motion. And let us consider an object which is moving such that x, y and z, all three coordinates are changing, then we can say that the object is in three-dimensional motion, as x, y and z, both all three coordinates are changing. So A is one-dimensional motion, B is two-dimensional, and C is three-dimensional motion. Study this chapter carefully. There are so many numericals in this chapter, and we'll discuss the uniform motion, non-uniform motion, average speed, velocity, etc. all in detail. We'll see you in next lecture. Till then, take care. Bye.